An experiment to measure the volume of a metal spherical ball is conducted. The ball is dropped into a cylinder of water. So there's the ball, and this is the cylinder of water that it's dropped into. The cylinder has a radius of 5 centimeters. So a radius of 5 centimeters. So the radius goes from the center to the edge. So the cylinder has a radius of 5 centimeters and a height of 9 centimeters and is half full of water. When the ball is dropped in, the water level rises by 4 centimeters. Find the radius of the metal spherical ball correct to 1 decimal place. So we're trying to find the radius of this spherical ball. So we're trying to find what the radius is of the sphere. So when the ball is dropped in, the water level rises by 4 centimeters. So this is the amount that it rises. So it originally was half full, and now it's risen up by another 4 centimeters. So the volume of the sphere is going to be equal to the volume of the displaced water. So the space that the water filled when it moved upwards, that volume is going to be equal to the volume of the sphere. So that 4 centimeters can be seen more clearly here. So that 4 centimeter height of water is going to be equal to the volume of the sphere. So the volume of the displaced water, well, the displaced water is actually in the form of a cylinder that has a height of 4 centimeters and a radius of 5 centimeters. So we're going to use the volume of a cylinder formula, which is pi r squared h. So the volume of the cylinder is pi r squared h, and we get that formula from our formula book. So we have pi r squared, so pi multiplied by the radius squared, and the radius we know is 5 centimeters. So pi times 5 squared, and that's multiplied by h, which is the height, which is going to be 4 centimeters, because the water level rose by 4 centimeters when the ball was dropped in. So pi r squared h, pi times 5 squared times 4. 5 squared is 25, 25 by 4 is 100, so we have 100 pi centimeter cubed. You can keep it as 100 pi for the moment. So if the volume of the displaced water is 100 pi, then the volume of the sphere is also 100 pi, because the volume of the sphere is equal to the volume of the displaced water. So the formula for the volume of a sphere is 4 over 3 pi r cubed, and we get that formula from our formula book. So we have 4 over 3 pi r cubed equal to 100 pi. So then what we have to do is cancel out the pi's on both sides. And then we have to solve for r. So we have 4 over 3 r cubed equals 100. Then we're going to do 100 divided by 4 over 3. Will give us 75, so r cubed is equal to 75. So then r will be equal to the cube root of 75, and the cube root of 75 is 4.2172, and that can be rounded off to 4.2 centimeters, because we're asked for this to 1 decimal place. So we were asked to find the radius of the metal spherical ball correct to 1 decimal place, and the radius is going to be approximately 4.2 centimeters.